You are welcome to this session. I'm always Wilson, your presenter. So today I'll be discussing how to generate a working formula for use in the preparation of a pharmaceutical product. This one is important, especially if you're going to prepare some products in a pharmacy lab or in higher levels. So, what is a product formula? We already discussed dosage forms and what it contains dosage forms. So, just a product formula contains the quantities of the active ingredients or the active pharmaceutical ingredients and their excipients. So, it just specifies the type of the active ingredient, the type of the excipients, plus the respective quantities. And the product formula, we can have official, unofficial, and also the working formula. All these ones are important in the pharmacy. So what is the official formula, or what we call the master formula? This one is usually derived from the official books or the pharmacopoeias. And these ones are usually in 1000 milliliters, 1000 grams, or sometimes as can be in 100 milliliters. Now, the unofficial formula, this one, of course, these ones are usually derived from the physician prescription or even from other sources. And these ones, they may or may not require adjustment during preparation. However, the official formula always requires adjustment, as we are going to see. However, after the calculation, what we get and what we are going to use to prepare our pharmaceutical products in the lab, or what we are going to measure, what we are going to weigh, is what we call the working formula, which specifies the quantities of the API and excipients determined after calculations for use in the preparation of a certain amount of a pharmaceutical product. So what your answers are always summarized in the working formula, as we're going to see how we come up with the working formula. Now, because these formulas are usually in 1000, depending on the volume or quantity, the formula can be reduced or enlarged to meet the specified quantity while maintaining the correct proportions of all the ingredients to the other. This one is important because if you're adjusting a formula, the proportion should remain equal. The proportions which were in 1000 milliliters should be the proportions which are in, or the ratios which are in what? In 50 milliliters. For example, in our pharmacy laboratories in schools, in like now institution here in Fort Portal, the formulas are usually reduced. However, they can be scaled up or enlarged, like for example, when you're preparing a sanitizer, liquid soap, or any other pharmaceutical product uh, which may require a larger batch or a larger quantity to prepare. But in pharmaceutical industries, of course, these ones are preparing drugs for the whole nation, for the whole region. The formulas are always the same, but for them they are enlarged or scaled up to meet a specified batch or quantity desired to be manufactured based on the orders. So it is important to understand that the product formula can be enlarged or reduced while maintaining the correct proportions of all the ingredients. So how do we calculate the working formula? Of course, procedure for calculation of the working formula. For the working formula, now there are methods like coming up with a factor, which we shall see later on, which I'll take you through. But for my preferred these short ones, uh, uh, method one, just get the quantity of the ingredients in the formula divided by the quantity of the formula times the quantity to be prepared. And for each quantity you're going to calculate, ensure you write the name of that quantity. Now, if you are given parts in method 2, just add the parts to get total parts. And then the parts of that ingredient you're going to prepare, divided by the total parts times the quantity to be desired to be prepared, gives you that quantity of that product. In case of ratios and percentages, this one use the principles which we have discussed in expression of strength and ratio strength. And also you can use first principles. First principles, if they are saying 1000 meters contains 50 grams of dextrose, but the question wants you to prepare 50 mils, will contain those first principles. In case of these words, 2s quite sufficient, add 2 to make, or 2, this indicates the total quantity of the product to be the total quantity of the product in the formula. However, sometimes this total may not be given to you. You may need to add the quantities of the ingredients to get the total quantity of the formula. However, only if they are in the same units. You cannot add a milliliters and a grams. No, they all should be in the same units. And I have put it in bold here. Never add if the ingredients are in different units. Which means that if the words 2 on or QS are missing, and then you see they are of different units, then there's a problem in that formula. Raise a request for correction or refer to the official books where they got it from. For percentages in the same units, one can subtract from the total percentage to get the percentage of the other, as we shall see. And the answer should have units. We talked about this weight per weight, weight per volume, and volume per volume. In the working formula, if the ingredient has the word 2, this one is not calculated, but we just transfer that ingredient in the working formula, and then we add, or we indicate the quantity to be prepared in the question. Some products which I will insist again, like a syrup, they are prepared in weight, and in case the volume is provided, please convert to weight using specific gravity. We saw this one earlier. The formulas containing sticky ingredients like syrups, semi-solids, these ones, it is a must to add an excess, at least not more than 30%, though other books may say 50%, at least not more than 30% of the total indicated to be prepared. For example, if you are required to prepare 50 grams of a product, at least you can use between 5 and 25 grams as the excess, which means that what to prepare will be either 55 or to 75 grams. However, sometimes for easy calculations, some people prefer to use 10 grams as recommended, but always state a reason of why you are adding an excess. For example, you can say these are sticky ingredients and they can stick on the containers. I have some practice questions here. You're provided with the master formula for dextrose oral solution. Write the working formula for preparing 30 ml of the product. This is the formula, dextrose, this. I just try to summarize for you here. Quantity to be prepared. So the total quantity of the formula is this. If there's a word 2, it is 2. That's the quantity, total quantity. But the quantity desired to be prepared is 30 mils, which means that dextrose, always write, indicate what you are calculating. Dextrose 10 out of 100 times 30 giving you this, and this water giving you this. Always it takes up these units. This one cannot become a gram, this one cannot become a mil. Your working formula should have a title. Working formula for dextrose oral solution 30 mils. Write the same ingredients which are given to you in a master formula, but this time indicate the quantities which you have calculated. Remember, for distilled water, we didn't calculate, we just transferred the quantity which was stated in the question. There is also this other one which is also important, determining the percentage concentration of each ingredient in the formula. Sometimes this is just a by the way. You can be required to calculate the percentage of concentration of each ingredient in the formula. And as we did earlier on, the quantity must always be in grams for weight and also milliliters for volume. But however, if I'm having milligrams and milligrams, it can remain in that. And to calculate the percentage concentration, it is the same thing as almost coming up with the quantities in the working formula. Here, quantity of the ingredient divided by total quantity times 100. As I told you, I don't put 100% here. No, it's set times 100. It is your answer which gets the percentage. And this answer should have a unit. Is it a percentage weight in weight? Is it a percentage volume in volume? Such that someone who is interpreting it for you knows what you did before. I have this question here. Calculate the percentage concentration of the ingredients in the formula of dextrose in the formula. So this is my formula. If I'm having the word 2, this is the total volume. So quantity is this one is 5 grams divided by this times 100. This gives me the answer of 0.05%. Remember, I've indicated for you here, it is a weight in a volume. If this was a milligram, I have to first convert it to grams. So this marks the end of the presentation. Remember, we're having very many questions in the quizzes in the Google Classroom app, and try to follow up and attempt as many as possible so that you can become conversant with the generation of a working formula. But this is a broad topic, as we shall be seeing in the preceding